Okay, for diagnostics, if it is having a problem that you can't fix with a quick cleaning calibration, there's a bunch of diagnostic tests we have in there. I can't remember which page it's on, but it should say test modes and have a big chart on it. Page 7, thank you. All of the diagnostics start by putting dip switch number 8 on. So we turn off everything else. Where are we at? Oh, there. Just dip switch number 8 all the way in the front. That's the only one that's down. Reset power. You have to reset power because the only time the CPU board looks at the dip switches is when you first apply power. It takes note of their position because you can disable bills and stuff by turning on dip switches. Then it ignores them. If you change them afterwards, it won't know unless number 8 was the only one on when you first applied power. Then the CPU board knows, hey, I'm in diagnostics mode. I got to look for changes because that's how we're going to get in and out of our test modes. If you look on the chart there, you'll notice that under number 8, it says E/D. That stands for enable and disable. Any of you that ever worked on 145s know the old VM401 box had an enable and disable switch. It starts and stops test once you select it by pushing the 3 buttons. We basically have the same system. We're going to be able to do the same tests plus a few more. But we're going to go at it differently. And the way we do it is we select the test by selecting a different dip switch according to the chart there. Once you've selected the test by selecting the dip switch, then we're going to use 8 as our enable and disable. It's on right now. To enable the test, we're just going to turn it off. To disable or stop the test, we just turn it back on. So to start off with at the top there, for a motor speed test, we can run the motor both forward and reverse direction. Motor speed for the transport motor is critical. We want to make sure that that bill is moving through there at the same speed it was when we went and took the readings for the bills to write the software. So we've got a certain tolerance range that we can run it at. So to test it in forward, we turn on number 1, turn number 8 off, just starts the motor up. As long as our test light stays off, we're good. If the test light comes on, it means the motor's either running too fast or too slow. I've never seen one run too fast. It's possible, I suppose.
I can't imagine how.
I can't imagine how either, but anything's possible. If you have an encoder, we had a thing once, there was one shipment of encoders, it was like 300 encoders, I think they caught it at the factory, where it had little pinholes in them from the plastic injection molding, and it was actually reading 2 for every flag that went past it, so that would read fast. But if it's running too slow, the majority of the problem you're going to have with this unit running too slow is dirt. Inside the validator. You know, especially with today's machines, more and more everything's going to be a video. There's still real games out there, but they're usually like Betty Boop and all that. They're the special games. The majority of machines are going to video. It gives you more options. You can put more coins in, multi-game, all that stuff. With a video, you got a CRT in there for right now until flat screens become ever more popular. But with a CRT, you got more heat. More heat is bad for electronics. You want to try and keep it cool, so they put the exhaust fans in it. Pull all the heat out of the machine. Unfortunately, all that air circulating is also sucking in through the validator and through the coin drop everything in the casino. Smoke, dust, dirt. On bar tops, who all likes bar tops? That's what I thought. I just want 3 minutes with the guy that invented those. That's all it's going to take. But all that dust and dirt gets sucked right through the validator. The amount of smoke and stuff, I know you've all seen, believe it or not, all the gears on here are white when they're new. I don't know if we can actually see the difference between this gear and this gear. They start to turn yellow. They will turn brown. That's tar and nicotine. It just gets sucked right through here and it builds up on everything. What causes a validator to run slow? One of 2 things that I've ever seen. Number 1, drink spills on bars. God, I hate them. Drink spills on bars get into the head and start coating there's 2 motor shafts or 2 rotor shafts in there. The forward one up here and the one in the back that drives the belts. The drink spill eventually gets in there. There's plastic bushings behind this shaft. And the shaft up in front here, you can actually see the bushing on this side. There's plastic bushings in there that the metal shafts run on. When that smoke and dust and dirt, and especially if you get a drink spill, it'll build up inside there. Eventually, it just starts to slow the unit down. First thing you want to check anytime you got a validator that's running slow is a quick head test, I call it. Just take and pop the head loose. Now listen to this. There's a little difference in speed. Not much, but a little bit. That's because you're no longer dragging the head and the belts that are inside of there. If you're doing this and you got one that's got the light on, it's running really slow, and you pop this head loose and picks right up and the light goes off, you got a drink spill in that head, I'll guarantee you. Just take the head apart, clean the bushings out, you're good to go. If it doesn't speed up enough to clear the error, on the validator, there's 3 sets of plastic bushings. And these are really hard to see. I don't even know if we can point these out, but I'll try.
Oh yeah, we can see that easily.
That little white bushing behind the roller, but inside of there.
Yeah, no problem.
There's a set of those bushings on 3 shafts in the validator. One of them is the back shaft here, the one all the way in the rear. That's for the upper belts. The shaft that's right in front of it, that's the back end of the lower belt. And the shaft that's up here in the front for the other end of the lower belt. Those 3 shafts have plastic bushings on them. If you've got a motor that's running slow, the first thing you want to do, and I know those of you who have done this are saying, oh no, disassemble the validator and clean those bushings. You would be amazed how quickly, I mean, it's going to take you a while to learn how to take one of these apart. It's not the easiest thing in the world. Yes, sir?
See more times than any of that black gear that's on the side of that gear right there that snaps in half at the spot and it just catches.
This gear gets broken tooth on it or something?
No, you're talking about the encoder flat?
Yeah,
This one.
that one right there.
Yeah.
Cracks and
Oh, on the side where it starts spinning on the shaft.
slows the motor down. You can push that all the way in to where it doesn't wear it in the same spot and it'll be fine for a while.
I don't know if you can pick this up.
Back up.
What are you trying to see?
Let me get my, oh, what did I do with my flashlight? I had a real nice Money Controls flashlight. There, that's mine. Thank you. If you take a look
Flashlight.
on the bottom side of that gear, I don't know if we're going to be able to see what I'm talking about
See the
here.
teeth? You see the
Yeah.
non-tooth part?
I've replaced at least 10 to 15 of those.
You're just getting started. I'm not going to lie to you. I'll tell you where the problems are. On that gear, the original gear, you got the flats up where the flags are, and then the part that sits down on the shaft. The teeth used to run basically all the way up to the flats where the flags are. That's the original style gear. When did they replace those, Tommy?
4 years ago.
So I was going to say 4.5, something like that. What they did was they left what they call a collar. They only run the teeth up about 2/3 of the way. And they left this collar up here. What that did was it strengthened it. The old gears, what would happen with time, inside a slot machine, the average temperature where the validator sits is 102 degrees. Somebody actually did a study and found that out. It bakes the plastic. The original plastic, over time, that continuous heat, it basically made the plastic a little bit brittle. And what you would get was down where the motor shaft was, you'd get a little tiny crack would develop. And you can't barely see it. You've got to be looking for it to find it. But when that cracks, it loosens up. That's just a press fit on that shaft. And when that cracks, it will loosen up. Yes, definitely it will slow the thing down. Most of those have been replaced. If you got some really old games, you may still find those older type in it. The new type with that shoulder on it, you won't have that problem. Because the extra plastic there in the shoulder not only strengthens it, they also made it out of a softer plastic. It's almost a nylon now. So we're not experiencing the cracking problem. Yes, that used to be a problem with them.
What year did they
Change to the new style? It was about 2000, right around in that time. 99, 2000, right around then. Constantly changing stuff. It's like software. Why do they always come out with new software for those WBAs? Because counterfeiters keep coming up with better and better counterfeits. Okay, so that's the motor test. Instead of dip switch 8, or instead of dip switch 1, if you use number 2, it's going to do the motor test in reverse. Same thing, it's just running the motor to make sure it's within that tolerance speed, but run it in both directions because it's got a brush type motor and you want to make sure you don't have a brush that's cracked or causing problems. Okay, so once we've got our motor speed right, next test we're going to do, I can't believe how long it's been since I've done the WBA, is the stacker test. No, yeah, stacker test. This is Dan Peterson in the back. For those of you that don't know him, he's my new trainer. When I first came to JCM, Tommy said, I don't want to go on the road anymore. And I couldn't understand for the life of me why. Being on the road, that's great. I love it. I was there 2 years. We hired Dan. Yeah, you can have the road.
Tommy's got a cute wife.
What are you trying to say about mine?
I Didn't say a thing about
Okay.
it.
Would you like me to?
No.
No, okay. I've been married a long time. I can say anything I want about my wife.
No, she's not here.
That's right. Okay. Number 3, we've already checked the transport motor. Speed on the transport motor is kind of critical. We want to make sure that bill is moving through there within a certain tolerance of what it was when we took the readings so that the bill looks the same and we can identify it. The stacker motor, on the other hand, not as critical on speed. All the stacker motor has to do is move that pusher plate, push the bill into the cash box. So if it's running a little slow, not too important. What we want to do with this test is just be able to operate it and make sure it's running smoothly. Make sure we don't have any broken gears or problems with that. So again, I've just turned on dip switch number 3, started up, turn number 8 off. All it's going to do is sit there and cycle that motor. The basic thing I do with this test is I listen. That thing should be making a certain noise. Shouldn't be chattering a whole lot of teeth of gears and stuff like that. You'll get used to the noises that these things make, and you'll be able to troubleshoot from them. Tommy used to amaze me. He can troubleshoot by noise. He can tell me anything that's wrong with the thing just by listening to it. But you want to make sure that the motor is moving smoothly. It's not catching. It's not real slow where it might be dragging. Listen to the teeth in the gear chain. Make sure you don't have a cash box that has problems. One of the things you're going to see with cash boxes how many here love their drop crew? Yep. God love them. If it wasn't for the drop crew, floor people, and soft count, we wouldn't have a job. Drop crew like to play kick the can, throw the can, toss the can. Soft count likes to play stack them up and use them for a ladder. Yes, you can destroy a can. One thing that I've seen is if it gets dropped on this back portion here, you'll notice that that black plastic sticks up a little bit higher than the metal in the back of the can there. If this gets dropped on the back, the only thing that's holding that in position, God, I love it when that happens, is this bracket down here. I've actually seen that bracket get bent from people beating cash cans. You get that gear clicking noise. You ever have one where you put the bill in and you just hear all kinds of noises in the back of the validator? One of two things. Either this has been dropped and that's out of position. All you got to do is just open up the cash can, tap it a few times with the screwdriver to straighten that metal out. Or, and this is my favorite, floor people have been helping you. There's two little metal legs down in the back and the bottom here. When the drop crew jams cash cans, and we know they always seat every one of them perfectly every time they go out there.
No matter which way they put it in,
Yeah.
right up or upside down.
I had a guy put a WBA cash can into a DVB 200.
And what size hammer did he use?
It's about 1/8 of an inch too wide. He got it 3/4 of the way in there, and then called us.
Oh, Jesus.
These things can get bent out of position. They get bent down. Problem is that a lot of people think the quickest way to fix that is just take a screwdriver and bend it up. Matter of fact, bend it up just a little bit. That'll make the cash can sit tighter. No, it'll just make it harder to get the cash can in. You want that thing sitting 90 degrees to the wall. We actually make a little tool that if you need one, you guys got my card? No, I didn't bring one with me.
It's a really cool little.
You got to hold
milled
TechFest
aluminum
more
lever.
often. Yeah.
It works perfectly. It's really
If you guys need one, you have my business card. If you don't get one before you leave, give me a call. I'll get you one. It just sits on there, you pick it up, and it puts it at the perfect level. What you want is just perfectly level. That's going to prevent that clicking noise in the back. Gears do get chipped, especially when you got drop crews that are slamming these things. I've seen them break teeth off the gearbox, or the gears in the box. It's pretty simple to change it. You take out 2 screws, the whole pusher met comes out. Inside of here, inside the frame? Those are fun to change, aren't they? You got to remember, this thing was designed in 1997. That's why we came out with that one. It's getting a little bit old. It's still reliable, still highly reliable. Maintenance-wise, once you've worked on these for a while and you know these diagnostics, these things are easy to work on because they'll tell you when they have a problem. They'll give you an error code. Okay, next test, number 4. Carrying and stacking test. See, I can remember this stuff. It hasn't been that long since I taught the class. Carrying and stacking test is basically an operational test. This is a functional test. It's going to run the validator, through the complete sequence of pulling a bill in, putting it into the cash box, and stacking it. The only thing it's not doing during this test is it's not trying to identify anything. It's not looking at the bill. You can run blank piece of paper, blank tickets through here at this time. It won't care. What I use this test for is intermittent faults. You got a validator out there on the floor, you get called over to a machine, hey, this thing did this and made this weird noise, and then it stopped. And you look at it, and the validator's out of service. You open it up, pull it out, take a look at it. Everything seems to be okay. You put it back in the machine, close the door, start it up, takes bills, working good. Well, but a minute ago it did this. I believe you, but I can't fix what ain't broke. It's working now. Intermittent faults will drive you nuts. If you're not there to see what happens or to hear the noises that it makes, it's pretty hard to start diagnosing it. And a lot of times what you're going to find is broken wires, bent pins on a plug, something's been pushed out of position, and when the motors in the validator vibrated just right, you lose connection on one pin. Unfortunately, it's when a signal needed to run down that wire. And the validator shuts down. It goes into a fault. Problem is, by the time you get there to take a look at it, it's vibrated back together and it's working now. This test here we use at the factory over here in Las Vegas. When we get new validators in, we're getting ready to ship them out. We test them, we put the new software in them, and then we run them in this diagnostic test 4 for 45 minutes. Big racks they put them on. They just put them on there, put it into test 4, start it up, and let it run. It's a burn-in. Basically, anytime you're dealing with electronics, if you've got new equipment, you want to let it run for a certain amount of time to make sure you're not going to have an electronic failure right away. This thing just sit here and it's just going to run through that cycle. It pauses so it doesn't burn up any motors, doesn't overheat anything. Just runs over and over again. The only thing that will make it start early is if you feed it a bill. The entrance sensors see the bill and it will take it. But other than that, it's just going to sit there and it's going to run forever. Techs like this one, this is the one everyone calls the coffee break test. Because you don't have to be there when this thing fails. If it has a problem for whatever reason, when it shuts down, when it gets the error fault, it's going to give you a code. Error code 4. This is the one where your boss ever catches you in the coffee break room when you're not supposed to be there. He says, what are you doing? I'm testing the WBA. JCM told me if I put it into test 4, it was best to just go get a cup of coffee and let it run for a little bit. He'll call me up, I'll back you up. Don't worry about it. I used to was a tech. But you don't have to be there when it fails. You put it into test 4, it's just going to run this diagnostic over and over again until one of two things happens. Either you come back and shut it off, or if it finds the fault, if those motors vibrate and you lose that connection just right, it's going to give you an error code. If you go in the very back of the handout, you're going to find 3 tables. Table 1, Table 2, Table 3. 1 and 3 are used for bill acceptance test. Table 2 is specifically for test 4 only. Actually, Table 2, if you'll notice, is a lot like Table 1. The only difference is you can do test mode 4 with or without the validator head. If you want to, you can pull the head right out. Go ahead and turn 8 back on to get it back into diagnostics. Repower. In addition to turning on 4, 4 is for the complete unit. If you want to test just the transport, turn on 4 and 1. That's the only difference. It's actually the next test on the list there. Turn off 8. It'll run without the validator head on. It's just not looking at any of the sensors that are in the head right now. That's the only difference. But in this test mode, if you have a failure, if it faults out, take your number of flashes, go to that error table. We had 4 flashes. What's error 4 on table 2? Jam of the transport. I opened up the transport lid. Now you know it's one of those transport sensors. And in a second we're going to get to where the transport sensor test is. You can check each and every sensor in this unit individually. So basically what that's doing is it's breaking it down. It's saying it's in this section here. This is where you want to look. Okay, next test. Test number 5 is for the solenoid. Up inside the back here, in the transport tray, we got these 2 little levers. They're anti-pullback levers. Sorry. Prevents someone from being able to string a bill back up out of the cash box. Ever since we put validators in slot machines, people have been coming up with creative ways of playing without paying. They actually used to string the bill. They'd attach something to the bill, string or cellophane. They'd let the bill go into the cash box, and then very slowly, very carefully, they'd pull it back out. We put these 2 levers in there and stop that. They may get it out, but it's going to come in pieces, and they probably aren't going to be able to use it again. Not to mention it draws more attention to them playing the machine. These levers are raised up out of the way by an electrical solenoid that sits underneath this bracket here in the back. Solenoids, in validators anyways, fail for one of two reasons. Number one, it's an electrical device. It's basically an electromagnetic coil that pulls a little pin up, moves the levers out of the way. Electronic devices can fail. Age, whatever, problem in manufacturing, whatever, they can fail electrically. The other thing that causes the solenoid in a validator to fail, remember all that smoke and stuff we talked about being drawn through there by those exhaust fans? It builds up down inside the back here and can build up on that pin. You get enough nicotine on a pin, and I'm talking a validator's been out there for 4 or 5 years. When that solenoid gets nice and warm, that tar nicotine gets sticky. It can hang up. Doesn't happen very often. This is a very, very rare problem, but it can happen. What this test does is just operate that solenoid. If you got one, you ever see one where you get a bill all scrunched up here inside the transport? Didn't go in. You pull the bill out, works fine. Thing with that one is, because that one used to bug me too, because you know it's that solenoid that's failing. You see that bill all scrunched up right in front of where those levers sit down, you know the solenoid didn't come up. But when you test it there at the game, takes the bill, no problem. What causes that is that solenoid gets heated up for whatever reason. I actually had one lady one time when I was working at the Paris who was sitting there, and I figured she had to be a cocktail waitress or hostess in a restaurant or something, because she had a bunch of $1 bills. And she's feeding 1, 2, 3, hit the button. 1, 2, 3. She had a stack of ones. So no, that wasn't her excuse. So I asked her, I said, you want me to go get you some 20s for that or whatever? No. If you feed him $1 bills at a time, it thinks it's a different player every time.
Well, that's right.
So you have a better chance of winning. Sitting there feeding ones constantly all night long, it's going to heat up that solenoid. If you get that solenoid hot enough and that tar nicotine gets sticky, you might hang up those levers. Now the bill gets stuck in there. Problem is, now the customer's lost money. So they call a floor person. Well, depending on how good a tipper they are and where they're sitting at in the casino, that could take them 5, 10, 20, an hour and a half, whatever, before the floor person gets there. They come by, they yank it out, they open it up, they see that bill all jammed up around in there, they go, you know what, maybe I better call a tech. So they close it, shove it back in the machine, don't sign the meal card, and close the door, and call you. You come over there, open it up, you see that bill, you go, aha, solenoids are bad. Yeah, I can check this out real quick. Close it, put it in there, feed it the bill, and it takes it. That's because between the time they warmed it up, got the solenoid to stick, and it stole that bill, then they called the floor person, which took them 10 minutes. Then the floor person played with it for another 5 or 10 minutes. Then they called you, and they never call you when you're 2 rows over. They wait till you're on the other side of the casino with a hopper all opened up all over the floor. Between the time it actually fails from overheating and you get the chance to come take a look at it, 20 minutes, 30 minutes, on a real busy night, maybe even longer than that, solenoid's had a chance to cool down now, and it may not stick. If you ever get one of those where you see the bill all scrunched up and you suspect a solenoid, tag it. Say, check the solenoid, send it back to the shop. Put it into test 5. It's just going to sit there and fire that solenoid over and over and over again. Let this test run 10 minutes. What you're going to do in 10 minutes, you're not going to burn it up, you're not going to overheat it, but you're going to bring it up to temperature to where if it's been operating where someone's been feeding bills, it's getting to be around that same temperature. And if it's hanging up because it's getting sticky, you're going to be able to see it. The solenoid levers are either going to flutter, they might actually hang up altogether, but 10 minutes is long enough to let that solenoid warm up to the temperature where if it's having a problem from sticking because it's dirty, you're going to be able to see it. That's what I use this test for. Okay. So that's solenoid. We've checked just about everything mechanically on here we can. We're down to sensors now. And there's 2 different tests for sensors. If you take a look on there, test 6 says it's for the head sensors. Test 7 is for the transport sensors. We're going to run out of dip switches here soon if we try and check all the sensors. We've got 5 optical sensors in the head. We got 8 optical sensors in the transport. 1, 2, 3, 4, 5, 6, 7. 7 optical sensors in the transport. Had to think for a minute on that one. We're going to run out of dip switches if we try and assign one to each one of them. So what we're going to do is we're going to separate the head sensors, the transport sensors, and give them their own test group. The way we're going to do that, once again, we start with number 8 on. To do head sensors, it says turn on dip switch number 6. So I turn just 6 on, then I turn off 8. I'm now in head sensor test mode. And if you turn the page, you're going to see a chart on the next page for head sensors. Now that we have turned on 6, turned 8 off, we're going to make 6 our enable and disable for all of the head sensors. And this way we can check each and every one of them. So you start with 8. To do a head sensor test, you turn on 6, turn 8 off. That puts it in head sensor mode. Now 6 is your enable and disable. What 6 is going to do for you here is it's going to isolate each sensor. If you're not careful and you forget to turn 6 off, you can check 2 sensors at once. Things will start failing all over the place, but you can. Okay, so according to this chart here, the sensors, the optics that we have, let me show them to you real quick. You've got the entrance sensors, which are these 2 little round ones in the front. They're infrared. They look through the bill. They not only detect the presence of the bill when they're both blocked and start up the motors, they also are actually taking a reading off the bill. They look through it. And then we have HPL, HPR, and HPC. That's the rectangular lenses on the bottom. These are a little bit different. These have both red and infrared light. They also have reflective and translucent sensors. Transmissive, thank you. I knew it was something like that. I knew it had a trans in there. There's also a barcode sensor up on the top. Barcode sensor, there's no physical check for it because barcode sensor calibration, although it is calibrated, the range is like this. Because with a barcode sensor, it's black, it's white. How long was it black, how long was it white? That's how those things work. So for the infrareds, you've got an LED on the bottom, photosensor on the top. For the HPL, HPR, little rectangular job, you actually have an infrared and a red transmitter. The red ones are on the outside. Also across from it on the top, and you'll notice that they're slightly off center, you have another set of LEDs, IR and red. What this does, as the bill's going through there, you get an infrared pulse that reflects off the bill. You also get an infrared pulse that goes through the bill. Same with a red. You got a red one that's being reflected. You've got a red signal that's going through the bill. So you're actually getting 4 different optical readings from each one of those sensors. The bottom LEDs are on for 50 milliseconds. They shut off. The top ones come on for 70 milliseconds. And they alternate. So, to test the sensors, we're going to do them individually. We've got 6 on. That put us in the head sensor test mode. First one on there is PT1. That's the left-hand entrance sensor. There's a little drawing on there. Should help you identify where these things set. So I've got 6 on. To check PT1, I'm going to turn on number 1 according to the chart. Now I'm going to 1 is the only sensor that's being looked at right now. All you have to do is take a piece of paper or that highly technical piece of test equipment you all have called Jack's business card. Slide it into the left-hand side. Okay, what did I do wrong, Tommy?
Turned on, plugged in, power supply plugged in.
Thank you. I knew I brought you guys along for something. This is how long it's been since I've done WBA. There's one more sensor in the head that I neglected to tell you about. I'm having a bad morning. The PLEVs. What are the PLEVs, you might ask?
What are the PLEVs?
Thank you so much for asking. That's these 2 little plastic levers down here in the front. When the gears move, they pop up and down. The whole purpose for them being in there is to prevent a second bill from coming in until the first one's in the cash box. What they do, you know how when a validator or when a WBA starts up, it cycles and then at the very end it gives you that little That's dropping these levers back down. They're out of the way now. You can put a bill in there. When you put the bill in, losing money like my wife's here. Oh, thanks.
Too ratty?
No,
Or is it a too low
that'll pay for dinner
denomination?
fine. That'll work too. No.
All right.
When the bill comes in, blocks both the entrance sensors, now the motor starts. The motor's going to pull that in, the O-rings catch it first. As the bill's going through there, those levers are being held down by the paper. But as soon as the bill passes them, they're going to pop up right behind it. Now, this bill, you can't feed another bill in there until this bill is already put away in the cash box, and we recycle the motor, kick them backwards, and they drop back down out of position. That's what the PLEVs do. Okay, so to test them, we've got those turned on right now. Just open up the validator head. You can either do it with the O-rings here or with the belts. And just rock them back and forth. That'll pull the levers up and down. When they're down, there's an optic sensor on the lower sensor board that sees the lever as it drops. So it's just looking to make sure that that lever is dropping into position, and that's so the CPU board knows what position those levers are in. That's what it's for. So that's how you test that one. I can't believe I forgot that. I got to get out and do WBA more. Dan's been doing most of the WBA classes. Alrighty. Check the next sensor. We got to turn 6 back on. Always make sure you do these in the correct order. You start the test by turning 6 off. To get out of it or to change it, you have to turn 6 back on first. That takes you out of test mode. Now you can switch which one you have on. So we're going to turn number 1 off. If you look, number 2 and number 8 say they're not used. That's because in foreign countries, the US, Japan, and Australia are the only 3 countries that are using magnetic ink currently. Brazil's looking at using it, but we don't know if they're ever going to go to it or not. With those countries that use the magnetic ink, we have 3 mag sensors in the head. For the other countries that do not, most of their currency, if you've ever taken a look at it, is really colorful. They use a lot of different colors. They also use a lot of very intricate patterns. There's some really beautiful artwork done on most foreign currency. Because they use optical features instead of magnetics for counterfeit protection, we add a couple of extra optical sensors in the head. That's what test 2 and test 8 are for. We take out 2 of the mag sensors because they don't have any magnetic properties to the bill. We leave 1 in there in case they have a stripe or whatever on it. But that's what test 2 and test 8 are for, in case you were wondering why they say not used. So we're going to go to number 3 for PT1. Turn on number 3. Turn 6 off. You guys were just going to let me sit and flounder with that, weren't you? Those are my friends. Yeah, just a couple of minutes. Why am I getting a light? Hold on. If you ever have something that fails or does something you don't think it should do, start from scratch. Turn number 8 on, start from the beginning. If you
Got a bigger hammer.
That will work sometimes. Okay, so I turned on number 3, turn number 8 off, or 6 off, I'm sorry. All you got to do is just go ahead and slide something into the build path and block the optic that you're trying to test. So when I slide this in here over on the left-hand side where that entrance sensor is, every time I block the optic, the light's going to come on. You're going to do the same basically with each and every optic in here. If the light comes on and you don't have something in there blocking the optic, you've had a failure. Either the LED is burned out or the phototransistor's gone bad. They're electronic components. They fail at times. If it does, what you're going to see is that light's going to be on and you still got the lid closed. You don't have anything slid in there. So how do you know which board to change? Do you change the lower board on the entrance sensors, in which case where the LEDs are, or do you change the upper board where the optics are? Thank you. As he's pointing out to me very easily, we're going to simulate the LEDs. Go ahead and open up the lid. For the entrance sensors, the LEDs are on the bottom, photo sensors are on the top. Just take your flashlight, LED flashlight if you got one. Actually, any flashlight will work. And simulate the LED by shining it into the photo sensor. If you can turn that test light off, there we go, with a flashlight, you know the photo sensor in the upper board's working. It's got to be the LED that's burned out if it stays on when it's closed. So you change the upper board. If you can't turn it off with a flashlight, then you know it's the upper board. The photo sensor's not working. Just a quick test to tell you which board has failed if you ever get one that doesn't work. Don't use that to test them. I had a guy in Colorado call me up 3 weeks after I taught the class up there. Said, hey, I got an error you can't fix. I said, oh yeah, what's that? He said, I got an error 5 when I do a bill acceptance test. I said, well, that means you got a bad head sensor. Nope, checked them all, they're all good. I said, no, you can't. One of the head sensors got to be bad. Nope, checked them all. So I said, okay, let's walk through it. And I went to turn on 8, turn on 6, da-da-da-da-da. We walked through it, and every time I told him check the sensor, yep, that one's good. Yep, that one's good. Got all the way done. I said, no, one of them's got to be failing. Nope, checked them all with the flashlight. They're all good. I said, well, what was it doing when the lid was closed? He said, huh? I said, when you had the lid closed, was the light on or off then? Well, I had the lid open so I could check them with a flashlight. I said, okay, so all your photo sensors are good. How about your LEDs? So we went through the test again. Sure enough, he had a bad LED. So we'll use that test only once you have one that fails. Use the flashlight to check it after it's done. Yes, Tommy?
You got a flashlight that's a really, really, really super bright flashlight.
Mm-hmm.
A lot of times you get a photo sensor and actually still reacting to it as bad.
Really?
That's interesting because it's degraded, but with that super amount of light, it shows good.
A couple lights that were like super intense.
The LED type?
Actually, no, it was regular incandescent, but it
Mag?
was like a krypton bulb.
Yeah, I've seen those.
And it actually made
So the photosensor degraded to the point where it wouldn't react normally, but when you got an intense enough light, it would.
Right, I still got to react. Basically, I was just saturating the hell out of it. So
That's,
I thought it was good, but the fact that
and that is why I never say never when I'm talking about anything with electronics.
Remember, I said the same thing. I hate to say never.
Never say never, because as soon as you do, somebody's going to say, oh yeah, come here a minute. I got one in the shop. I want you to see.
I got your never right here.
Okay, so basically I can walk through all of the sensors. 6 on, turn 3 off, turn 4 back on. Whoops, there we go. 4 on, 6 off. That's my right hand entrance. And so on. 6 back on, 4 off. 5 on, 6 off. That's HPL. Now to slide a card in there, you got to push it a little harder. You got to get past those O-rings that are right near the front now. I usually use, actually for this type of testing, I use either my ID card or your slot card or whatever. It'll slide past those rollers a little easy. You can use a business card. You just got to be careful when you're pushing it in. 6 is the tricky one. 6 is for HPR. So I'm coming out of the left-hand sensor. I turn 6 back on to get out of test mode. Turn 5 off. Just leave 6 on. Remember I said you could test 2 sensors at once? If you have 5 on, let's do it. If you have 5 on to test HPL and you forget to turn 6 off, especially if you're doing it with a flashlight test, well, that's HPL. Let me check it here. Oh, it's bad. No, it's not. I left 6 on. When I left 6 on, I'm also checking that one at the same time. I got to shine the light in both of them. So that's why when you're doing the test, you want to make sure you're very careful and you turn 6 off after you select whichever sensor you're testing. And the last one, of course, HPC. Just turn 7 on, 6 off. Same thing. That's all the way in the back. HPC. So that's the head sensors. Pretty quick and pretty simple. You're not going to become an expert troubleshooter when you leave this class. And that's because, like anything else, and this is one thing I found true, especially with slot techs, and I'm one of you, so I'm not trying to say anything. This is how I learned cars. My brother used to teach me all about auto mechanics. He's an auto mechanic, been one all his life. I was 10 years old, I started helping him. And he said, yeah, when you do this and then you do that, then that makes it do this. And I said, oh, really? Yeah, let me get my hands on it, because I don't believe you. We learn by doing. So if you get a chance, take this booklet. When you get back to the shop, you get a little bit of free time. Yeah. Unless, of course, you're working swing shift. I hated swing shift. Play with these things. Just go ahead and take a good one on the shelf and run through these tests. You'll get to the point where you know all the diagnostics by heart. It's not that hard. Okay, so we're done sensing all of our head sensors. Now we're going to check the transport sensors. I highly recommend that you take it out of the frame for this test. There's a few sensors you can't get to while it's in the frame, and it just makes it a whole lot easier. You don't need the frame for any of the transport sensor tests. So again, we're going to start with 8 on, reset power. Instead of using 6 for the transport, we're going to use number 7. If you go back to the main page, it'll tell you turn on 7 for transport sensor test, turn off 8. And just like we had for the head sensors, we're now going to use 7 for our on and off switch, our enable and disable. If you turn to the next page, you'll see transport sensors. You'll see a little picture locating where the sensors are at and the list of which dip switches you're going to use to test these sensors. Let me run through their location real quickly for you. First one is the entrance sensors. That's these 2 little plastic levers sit right in the front of the transport. Underneath there, underneath the transport tray, if you took a look at that lever, it actually looks like this. Down underneath there's a little leg that hangs down. It's hinged up in the front. And below there's an optic that sits right on that leg. Lid's closed and there's nothing in the transport. When you open the lid, this is actually on a spring. It'll actually pop up just a little bit and that leg will swing back behind the optic. That's just letting you know somebody didn't get the lid closed. It's still open. When a bill goes through there, it pushes it down, the leg moves forward. So it's a two-way switch. It'll tell you either somebody didn't get the lid closed or you've got a bill that has reached that point in the transport. Number 2. When those levers come up, once again, you got an optic inside there. There we go. When the lever comes up, there's an optic in there. The levers block the optic. It's just a positional sensor letting you know that the levers have been pulled up out of the way and it's going to take a bill now. Next one. This one's a little hard to see, but anyone who's worked on these for a long time will know what it is. It's the feed-out optic. Sits down here at the bottom of the bill path where the bill comes out. The LED and the photo sensor are both mounted on this board on the inside. Sitting across from it, you have this, it's called an F-out guide. Anybody who's a parts person knows that name. Has a little triangle shape here in the middle. I don't know if you can really
Hard to discern.
pick that up.
There, oh yeah, there you go.
Right here in the middle, there's a little triangle shape on it. That's a prism. That's what's used to reflect the light. Let me draw it on the board real quick. It's got the little teeth that help guide it into the tray. And there's a piece of black ABS on the inside of the bill path, and the board's mounted down here. LED and photo sensor. The LED shines the light across the bill path. It reflects on a prism just like a Bally coin-in optic. Shines back down into the photo sensor. That's the one to let you know that the bill has. Next two are these two on the back. Those two optics right there are used to look at these two levers in the back. That's going to give you all the information you need to know about what's going on inside your cash can right now. And I had to go and bring this stand. I can't do it right now. Basically, when the pusher plate starts to move, and those of you that have played with these for a long time know, this little block down inside of here moves out of the way. That's going to allow the left-hand lever there to drop down out of the optic. So that's letting you know the pusher plate is no longer in home position. Home position's all the way back. We have to make sure the pusher plate is in home position so that the bill can come down into the slot as it's being fed into the cash box. If the pusher plate's out of home position, that's blocked and you can't get the bill into the cash can. So that's a positional sensor letting us know that pusher plate's all the way back. Go ahead and put the bill in the cash box. The other one, the one on the right-hand side, is just to let you know whether or not the cash box is fully seated. They actually both move, but the one on the right-hand side is to let you know whether or not the cash box is all the way locked in.
That's this one.
No,
This
right-hand
right?
side as you're looking on the
Oh,
front.
Oh, okay. Oh yeah, I can feel it now.
Actually, if you move that one, you can hear the pusher plate.
Right.
So that's what those two optics in the back of the transport are doing, letting us know what's going on inside the cash box. Last two optics we got are those encoder gears. We spoke about this one, the one with 4 blades on it. This is on the transport motor. This is the motor that drives all the belts. Belts in the head, transport, and cash box all come off that same motor. 4 blades on it. This is how we judge the motor's speed. Counts the blades as it's going through there, compares it to a time interval. On the other side, we got one that's got 2 blades that go through the optic. This is our stacker motor. All this one does, all these gears on this side, are just to help move that pusher plate, push the bill into the cash box. So to start checking these, once again, for diagnostics, we start with number 8. Always start with number 8. Apply power. We're going to turn on 7, turn 8 off. And according to our chart, the first sensor, our entrance, those 2 little plastic levers inside, is dip switch number 1. Turn on number 1. Turn 7 off to single out or isolate that sensor, and open up the lid. Thank you, Randy. When I open up the tray, remember I said that thing's going to pop up? Actually, if you push it down real slowly, you'll see that's the position it sits in when the lid's closed. Keep on pushing down. That's what happens when a bill goes through there. So it's just moving that leg down beneath the tray, in and out of that optic. So that's how we're going to check the entrance sensors. You got to do it real slow.
Through that too fast.
Yeah, if you're sitting there pushing on it, you might see the flicker, but you can't really tell. You just got to do it real slow, or just open and close the lid. It should go off when you close the lid and latch it. Okay, next one. 7 back on, 8 off. Going to number 2. Excuse me. This is for our solenoid levers. If you have this style of solenoid levers that looks like this shape, it has a lockout built in, a mechanical lockout to prevent someone from being able to slide something in there, push them out of the way. To test this one, you got one of 2 ways. There's one screw in the front of that cover. Take the screw out, pull the cover off, and now you can just mechanically,
Sorry.
it's okay. drop it. Or, if you're out on the floor and you're using one of these handy extension harnesses to test it at the game, you can actually be very careful about it. Slide a card in there. There's a pin that runs across. All you got to do is just drop that pin out of the lock, and you can move it mechanically. But that's the one for the solenoid levers. When the levers go up, the light should go out. Next on our list is the feed out sensor. That's dip switch number 3. Everything goes from front to back, left to right. So if you start in the front, that's number 1, number 2, number 3. Batteries?
No, my money control's flashlight's already failed.
Would you like a JCM flashlight? I've got plenty.
I do want a JCM flashlight.
You take our nerd pack, put it in your dashboard, because sooner or later you're going to drop one of those screwdrivers down the vent on the dashboard, and you'll need ours to dig them out with. Everybody gave you a screwdriver today.
Yeah, we really got some good stuff today, didn't we?
Okay, so turn 3 on, turn 8 off. All you got to do is slide something into the bill path there and block that feed out optic. Don't let the light get to the prism. I will warn you on this, don't use a dollar bill. The very edge of a dollar bill where it's white, there's no printing on it, if you slide that up in there and that's all the farther you slide it in, that infrared light will go right through that white paper and it won't even see it. Also, don't use a lot of bright overhead lights. Even with a card in there, I can get it to turn off.
Oh, you can't you? Look at
Sure.
that. Yeah.
If you got a bright enough light over your bench,
Yeah.
you're going to start fooling optics. It can cause problems. Okay, so that's the feed out. Next, let's get to those 2 on the back, the ones that tell us about the cash box. How am I doing on time? I know it's got to be getting close to break time.
Yeah, I think it's 4:30. Yeah, 4:33.
4:30. Oh, geez, I'm running real late.
No, you're not running really late. It's exactly break time because you started at 3:30.
Okay. Number 4. Turn 7 off. The light's going to come on right away. That's because these 2 optics in the back normally are blocked by those 2 levers in the transport frame. Also, if you take a look at them, I don't know if we can see it, they're labeled
Oh, sure.
S1, S2. S1 is the one for the feed out, or I'm sorry, for the pusher home. So all you got to do is,
Get the light out of
yeah,
there.
when you block it, that's the normal condition that it's in when it's in the frame. The lever's blocking it, it's going to turn the light off. So these 2 kind of check backwards. Next one, go to number 5. Again, turn 7 on first to get out of test mode. Change my test to number 5. Turn 7 back on. Same thing, just S2, the one right next to it. Oops.
Am I doing? No.
No, I'm missing it. Okay. And the last 2 sensors, pretty easy. Once again, 7 back on to get out of test mode. Turn 5 off. Go into number 6 for the transport motor. Turn 7 off. Transport's the one with 4 blades. All you got to do is just come over here, rotate the blades through that optic. Should toggle your LED on and off.
Easy peasy.
And then 7 back on, and just like we had for our head sensors, we got one where we leave the on-off switch on. This is it. Turn 7 on, we lost video.
Yeah.
Okay. Leave 7 on, and rotate this gear through there, or the flags through the optic.
Oh, where's the LED there?
So that's all of our transport sensor tests. And you're looking at the chart going, but there's one more test here. They call it a head detach test. What is that? I'm so glad you asked that question. Inside the validator head, you got board on the top with optics and sensors on it. Got a board on the bottom with LEDs and sensors on it. This harness runs between them, connects the 2 of them. Now we got to get all that information from the lower sensor board down to the CPU. Like your board. Little tiny harness runs to this plug in the back. That one plugs into, where are we at on video? Oh, you're using that one.
Well, don't you want to do that?
Yeah, I'll do it. That one plugs into the one in the back of the frame, which, if you look down in back of there, has a little tiny harness that finally plugs into the CPU board. So what we got the lower sensor board, plug on it, little tiny harness that sits underneath that tray, that goes to the plug on the back of the validator head. That one plugs into the one on the transport, which has a little tiny harness, which has a plug that goes into the CPU. So you got 3 connectors. 3 chances that I was the guy working graveyard last night, and I wish I'd have brought my extra sensor board. And when I was troubleshooting this thing, I found it had a bad CPU board. No problem. Take 3 screws out, slide the tray after you disconnect everything. Change the CPU board, plug it back in. Of course, as I'm getting ready to plug that back in, I happen to look up the clock and notice that it's 10 minutes to midnight. And I know my shift ends at midnight, and at 12:01, my wife's going to be waiting out front for me. 12:02, she's on the way home, whether I've made it to the car or not. We have been married for 34 years, going on 35. So in my haste, I go to push that plug on. I don't quite get it snapped down. I don't get it tight all the way across. One end's just a little bit loose. It's still making contact, so I do my test. Everything works. No problem. Set it up on the shelf. Someone comes by, takes it, puts it up on the floor. And after about 6 months or so, the vibration of that motor and stuff works that connector, and it comes loose on one little corner. I lose sensors. No problem. JCM told me how to check sensors. I'll just go into test 6 and check them all out. Hey, my left-hand entrance sensor isn't working. Flashlight test. Which board is it? Check it with a flashlight. Upper board's not working. No problem. Change the upper board. Of course, it still ain't working because down inside, and you can look, but you ain't going to see it. You changed cameras on me. It's impossible. You can see the harness down there.
God, for a non-smoker.
And I quit
that's terrible.
smoking, yeah. You can see the harness down there, and you can almost see the plug if you get it at the right angle. You can't really tell whether or not it's plugged in. They wanted a quick, simple way to check that circuit. The plug that's hidden up underneath this tray cover, and the one that's hidden way down there on the CPU board. So what they did, really simple, sliding on there. Okay. They took a signal on the CPU board, and they ran it up the pin on the very edge of the connector. Get it all the way up to the lower sensor board, take it across through a circuit, bring that signal back down the other corner. If you can get that signal from this point to this point, all 3 of those connectors have to be plugged in all the way across. They call it the head detach test. Basically, it's a circuit loop to check and make sure all the connectors are done. You got 7 on already? Turn 7 off. If you get the light, you have a complete circuit. If you want to test it, just pop the head loose. That's disconnecting one of the 3 connectors. You lose the light. If you're ever doing head sensor tests, because you got a head sensor failure and you're doing a head sensor test and one of them fails, before you replace a board, do this test, just to be sure. That way you know it isn't one of those connectors got loose somehow and you're chasing a ghost. So that is all of test 7. We are left with test 8, and you said it was 4:30? We will do test 8 after we get back from our 10-minute break. Okay, bill acceptance test is a self-diagnostic. This is used to not only check and make sure it's identifying bills correctly, but it's also testing every sensor in the unit. And we got 2 different ways to do it. You can do it with just the head and transport out of the frame, just like this, or you can do it in the frame with a cache box. If you don't have a fairly good idea of what's going wrong, if you suspect a head sensor, fine, do the bill acceptance test like this. But if you're not really sure, just, it comes back into the bench, and I used to love this. I was a calibration tech at Fiesta. We had 24 spare DVB 145s. Every night, I had 24 to calibrate. Because as soon as they found out I knew how to use the scope and I was calibrating them every night, nobody troubleshot from that. You got a validator problem? Here, let me get you another one. 24. They all had a nice little yellow sticky note on it to let me know what was going wrong. Bad. AFU. Don't work. Anytime you take a validator back and you got an idea what it is, write that on the note. Your bench tech will love you. But if you don't have a good idea what's going on, I always recommend, first time you check it, do it with the frame and a cache box. If you're doing just a head transport test like this, you're not checking those 2 sensors on the back that look for the 2 levers in the frame. Okay, so start with number 8 on, just like we have for every other test. To do it with a frame and a cache box, we're going to turn on 1, 2, 3, and 4. We're back on the first page. Well, actually, it's just beyond transport sensor test also. Dan made me up a new handout. Turn on 1 through 4 all at the same time, then turn 8 off. It's going to cycle up just like it does inside the game, and it's now ready to accept and identify bills. How's it going to identify the bill, you might ask?
How's it going to identify the bill, Jack?
Thank you for asking. Number of flashes on the LED. Take a $1 bill. As it's going into the cash box, one flash, $1 bill. How many are you going to get for a 5? It's always one smart aleck who's done this before who spoils it for me. 5. That's the most logical answer. It's wrong, but it's the most logical answer. 2?
2?
That's the second most logical answer, but it's also wrong. Basically what they did, because we have software for 80 different countries right now, same validator, different head, 80 different countries, they wanted to make the codes all similar. But if you take this thing to Russia, it takes 500 rubles, 1,000, 5,000, 10,000, and 50,000. Nobody wanted to count 50,000 flashes. So what they said was, if it is a legal denomination of currency, we're going to give it a code. So although we don't use them here, $2 bills are still legal in the United States. So you get 1 flash for a 1, 2 flashes for a 2. It's not even in the software. It won't take $2 bills. 3 for a 5, 4 for a 10, 5 for a 20, 6 for a 50, 7 for a 100. Oh, you probably don't have a 100 either. You're married. So if I put a 10 in here and forget to take it out of the cash box later,
You missed dinner last night.
I get to go to McDonald's, huh? 1, 2, 3, 4. So that's how we're going to identify the denomination of the bill. When you're doing bill tests, maybe you got one back in the shop, cleaning and calibration, you always want to do a bill test, make sure it's identifying correctly. That's how you're going to know what bill it took, or what code it's sending to the machine to tell it what bill it took. Pardon?
How many bills would you put in?
If I was bill testing it, I'd put at least one of each denomination, and I'd probably do them 4 or 5 times each. Doesn't hurt. Never hurts.
Forward and backwards.
Right side up, upside down. I get paid by the hour. At least I used to when I worked for a casino. Now I get paid, well, I get paid weekly, very weekly. God, I can't believe I stooped to that one. If it has a problem anytime during acceptance, it's going to issue an error code. This is the same thing it's doing in the game. If it has an error with a validator in the game, it sends a hex code to the machine. Here's the problem you're going to run into with diagnosing it from what the game is telling you. If you look at Table 1 and Table 3 in the back of the book, Table 1, I believe, has 7 error codes. Table 3 has like 10 or 11 or 12. It says 15. There's a couple skipped if you look at the numbers. There's like 20 error codes that we can generate to help you narrow it down to what part of this validator is having a problem. You go to a Williams game, there's 4 error codes for a validator. No cash can full, validator error, and validator communication error. They take 20 errors and distill it down to 4 different codes. A lot of times you're going to, and games will do this, you'll know that if it says this error, yeah, it's probably this is what's going on. But if you want to get down to diagnosing exactly what sensor groups you need to work on when you're back in the shop, put it into the test mode. You're probably going to get the same error code anyways. But with this, you take that error code, if you go on the chart there, first it's going to give you a description of it. I haven't seen the new chart, so I can't remember. Yeah, and right next to it on the right, it not only tells you what sensors are involved with that, but also tells you what diagnostic tests you got to do to check those sensors. So if you're having a problem with a validator, real simple. Test 8, bill acceptance test, or maybe test 4, that intermittent test, the one that's looking for the loose pins, broken wires. But one of those 2 tests, if you play with it long enough, is going to give you the error code. Take the error code, go across on the chart. Those are the sensors you need to check. Go into test 6, go into test 7. Use your cell or your transport motor test, your stacker motor test, whatever you got to do to check that sensor, and you can isolate it down to what it is. When you're doing sensor tests, especially if you're doing transport, you got this out of the frame. When you're doing those tests, wiggle wire harnesses. A lot of times it's not the optic and it's not the plug. Could be just a wire. Maybe it's got a bad connection at one of the connectors. Wiggle the wire harnesses while you're testing the sensor. Could be it's a bad connection there. But it's pretty easy to diagnose with this thing. Using test 8 or test 4, it's going to give you an error code. Take the error code to the chart. Now you know what sensors you need to test. Troubleshoot it down. Is it the optic? Is it the wire? What's going on with that? Yes?
Down in main 4,
On the CPU board? Really? First time I've heard of that one. Anything's possible. Remember our old, how many of you still working on DVBs? The harness that goes from the head to the transport? That plug on the transport board? That'll develop cold solder joints all the time from people yanking on the harness. Probably the same thing. They're probably yanking on a connector and developing a cold solder joint.
I got a question.
Sir,
Are those rollers in there? Like,
inside the head.
yeah, gunk that goes up.
Yes.
Is that mostly dead skin? That's my boss.
Isn't that I love it when people use that. Is it mostly dead skin?
I think it's dead skin.
I don't know how much mostly it is, but yeah, there's probably dead skin cells on there.
Tommy told me that they haven't analyzed them. In fact,
Oh yeah. Though you shed your skin, what is it, once every 15 months? Completely, but the surface layer, the epidermis.
exfoliate continuously.
Yeah.
That's what those.
You're constantly losing dead skin cells. Anyway, who used to sell Kirby vacuum cleaners?
Did you really?
You did the mattress test, right?
Yeah, yeah.
You did the mattress test with, look at this dead skin. Yeah, it's a great selling point. Yeah, you're constantly shedding skin. It is, what's on those rollers is cigarette smoke, dirt, fiber from the bills, dead skin cells, oil from the skin, grease off of mechanics' hands, food off the restaurant guy's hands. Yeah, it's everything. Everything gets all over inside there.
Creepy, huh?
The best thing I've ever heard for cleaning those was a kid's battery-operated toothbrush. The thing you want to avoid,
The Little Mermaid toothbrush.
yeah, I wouldn't use Little Mermaid. I use Daffy Duck myself, but that's personal preference. If you want to use Little Mermaid, we have a saying for that in the Navy, don't ask, don't tell. You don't want to use something metal on those rollers in the head for a couple reasons. Number one, it's right next to that lens. You slip off there, you scratch the lens, now you got to replace the lens. And pulling this apart to replace the lens is a whole lot harder than just cleaning the rollers. You want to use something that's as soft as a plastic or softer, yes?
What about a thermal tool with polish? The fiber polish?
The fiber one?
No, cloth like.
Like a jeweler's buffer kind of wheel. Yeah, I've seen those. I can't imagine.
Yeah.
It's soft. It's real soft.
You want to be careful.
It's fast as hell.
Yeah.
If you heat up too much.
I don't know if, yeah, that's the only thing I worry about is heat. I mean, if you got a variable speed Dremel and you want to slow it down a little bit, yeah, probably work good. The kid with a battery-operated toothbrush usually has a rotating head on it. And that, if you hold it at the right angle, you can make the wheel rotate and still clean the stuff right off at the same time. Works really good. Plastic hopper knife, acid brush cut down real short. Just something that's as soft as a plastic or softer so you don't scratch it. It's what you're worried about inside of there. Okay. Anybody got any questions on the WBA? They're all working good. You're not having any problems. You're getting rid of everything else on your floor but WBAs, right? All right.
What about the motors that overheat and melts the plastic?
Yes. Which machine is it in? IGT?
Shell.
I've never seen an IGT do it. I'm not saying it doesn't, but I've never. I mean, anything's possible.
Someone put it in motor test and left it in motor test too long and just simply melted it. They just get out of the game.
There used to be a game. Yeah.
Good question. I need to get some instructions from you when you send your customers.
No problem. They're on the website. Yeah, everything for the Sentry, for the IGT, and for the jack bezel, they call it. All those are now downloadable on our website, which I'm going to get to in just a minute. Motor, melding. Who was that? Videotronics? There was one company here in town. They're no longer in business. They had, it was actually a diagnostic built into the game. If the validator had a failure, if that didn't clear it, it would send another reset. If that didn't clear it, it just kept doing it over and over and over and over again. We first noticed this at the Klondike, which, as we all know, is one of the most popular casinos in town here. Unfortunately, these two machines were sitting in a corner where nobody went. Some guy put this into a bill validator error, and it just sat there and cycled and cycled and cycled and cycled until it melded the motor. It is possible to overheat the motor that way. Most of the software nowadays, we did this 2 years ago when we found this problem with this machine, because they're not going to, don't ever try and get an OEM to change their code. It just isn't going to happen. So we wrote it into the software. It was IDO 15, IDO 11, IDO 15 software, where if it gets more than 5 resets within a certain amount of time, the validator will shut down and go into a fault. I think they have put that into all of the software now. Don't hold me to that. But yeah, if you get a motor that's overheated, the first thing you're going to hear is that doggone encoder gear starts making all kinds of racket. Just gets noisier than heck. Look for the screws. If you ever got one that's got a real loud encoder gear, first thing you want to do is push on it, see if it's the old style and it might have cracked and you can move it. If you can't, take a look at the 2 screws that mount the motor. Because if that motor is overheated and it's tilted, you're going to see it. You're going to see the plastic is melted.
So do we send it to you or we dump it?
So you're saying change the IDO?
For $75, yeah, send it to us. We'll send you a brand new one. Or recondition one.
Do you recommend change the IDO then? If it happened in that?
Changing the software? If you have the latest version of software for that machine, it should fix the problem. If it doesn't,
If it's an old IDO though, that you're saying you should change it then?
we first noticed it in IDO 11, IDO 15, which works in the old Sigma games, in Videotronics. Universal used to use it. There was 2 other manufacturers. I can't think of their name right now. They use IDO 11, IDO 15, which is just a different protocol. IGT is IDO 22, 23, or IDO 24. Bally now uses IDO 03, used to use IDO 44 for the DVB 200s. We fixed it in that one, and I believe they have put that fix into all of them, that if it gets that reset signal 5 times within a certain time frame, it will shut the validator down. If you have a unit right now that is doing that, first thing I do is I check the version of software, go to our website and check and make sure it's the latest version. If it isn't, I'd upgrade to the newest version. If it is the newest version and it's still doing it, definitely let us know, because we want to find out what machine that is and what's causing it to happen. We will fix it if it's a software problem. If we can fix it with a software problem,